Welcome back to the fourth day of the session. That is advanced tools with reference to qualitative and quantitative data analysis using NV, IVO, and JAMOVI. So as a part of the fourth day session, today we are going to discuss about correlation test, regression test, and chi-square test. These are the three important tests any researcher mostly they used to conduct as a part of in their research work, whether it's for writing research paper, as a part of the dissertation, even as a part of the research project work. Now we'll see one by one, step by step, how one can conduct a correlation test, when to conduct the test, what this particular test is all about it, what are the data requirements, and with the help of the data set, we start understanding how one can interpret the findings, how one can report the research results. So for every test, like correlation, regression, and chi-square test, we'll discuss all the important steps, step by step, how one can conduct it. So coming to the first one, correlation test. Correlation. In previous session, we have done with the independent sample t-test. Independent sample t-test. As a part of independent sample t-test, we have discussed about two groups. One is independent variable, second one is dependent variable. We have two variables. We have differentiated between male and female. We have differentiated between athlete group, non-athlete group. So they required two variables. One is a dependent variable, that must be interval or ratio. Independent variable, that must be categorical data. Whereas when it comes to the correlation test, in order to conduct the correlation test, we required two quantitative variables. What I means to say quantitative variable means if you have data of like interval data, ratio data. In addition, other than nominal and ordinal variable, if you have any kind of quantitative data, metric data, or can say that scale data, in that case, one can go for correlation test. It is also known as Pearson correlation test. We have different types of correlation test. Within the correlation, we have different types of correlation test. Pearson correlation, partial correlation, and Spearman correlation. As a part of this particular workshop, I'm going to talk about Pearson correlation test. That is part of parametric statistics. Parametric statistics, as we are talking from the day one, what is meant by parametric, what is meant by non-parametric. In order to fulfill the assumptions of certain test, parametric test, if you're able to fulfill it, one can go for Pearson correlation. If you're not able to fulfill the assumptions, one has to go for Spearman correlation. Now, the main objective of correlation test is to understand what is the strength and direction of relationship between two quantitative variables. Strength and direction. What is meant by strength and direction? Let's take, for example, we have an example here. There is no significant correlation between the level of legal awareness and the incidence of domestic violence in urban areas. Now, here I have two quantitative variables. One is legal awareness. I have collected data from my respondents, how much legal awareness they have it. For example, imagine that I have around 20 questions. Okay, for out of 20 questions, how many, I'm just looking at out of total 20 marks, how much awareness they have it. If I'm counting, if I'm measuring their level of awareness. So that is going to be one quantitative data. Some of you might be having 18%, 18 out of 20. Some of you might be having 10 out of 20. Some of you might be having 17 out of 20. So basically I have quantitative numbers, right? I have some numbers. It may be discrete data. It may be continuous data. Let's take, for example, if I take height and weight, these are the two quantitative variables. Like 6.5, it is a continuous variable. If I ask how many children do you have it, that is a discrete variable. So whether it is interval or ratio, these are known as continuous data. It is all known as quantitative data. As a part of this particular hypothesis, I am saying that there is no correlation between level of legal awareness and the incidence of domestic violence. Means the people, those are having good amount of awareness about laws, but in certain legal sections. What is the commitment in terms of incidents? Number of incidents are taking place. The people, those are having legal awareness, are they committing domestic violence? Right? Maybe you can also see the number of incidents. The people, those having legal awareness, how many times they are committing domestic violence, how they are acting, what kind of activities they are taking place, number of times, number of incidents. So I just want to see, is there any relationship between legal awareness and incidence of domestic violence. This can be one correlation test. For example, the people, those are having high legal awareness. What about incidence of domestic violence? Is it high or low? Now here, there are three types of relations can take place. One is positive correlation. Second one is negative correlation. Third one is no correlation. With this reference to this particular example, level of awareness, if the person who is having high awareness, the number of incidents is increasing or decreasing it. Number of incidents is decreasing or increasing it. Similarly, I can also see that, for example, demand increases, supply increases. It is called positive correlation. As you can see here, demand increases, price increases or supply increases. It means if x-axis increases, y-axis also increasing. It is called positive correlation. If x-axis increases, y-axis also increasing. It is called positive correlation. Means if one value of particular variable is increasing, the other variable also increases. That is called positive correlation. On the other hand, we have negative correlation. Means x-axis increases, y-axis decreases. A value of one variable increases, the value of other variable decreases. This is called negative correlation. There is also possibility that neither increasing nor decreasing it. So there are three types of relationships: positive correlationship, negative correlationship, no correlationship. Now, as a part of the particular definition, strength and direction. Direction means, is it a positive direction? Is it a negative direction? Or there is no relation, there is no direction. Now, when it comes to the strength of the relationship, we are going to take with the help of the statistics. Based on this particular statistics, let's take for example, as you can see this particular figure, based on the test value, R value that you are going to get it. If the R value is less than 0.330, it means negligible correlation. If it is plus minus, depends. If the value that you are getting it, if it is less than 30, less than 0.30, it means there is a negligible correlation. In case, if it is coming under minus 0.30, it means negative correlation, negligible correlation. Let's take, for example, take this particular figure. What are the tests that you are conducting it? The final result, if it is coming between 0.70 to 0.90, it means high positive correlation. In case if it comes like minus 0.70 to minus 0.90, it means high negative correlation. So one can take plus minus accordingly, whether it is going to be high positive or high negative correlation. So the strength of the relationship depends on the test value, the R value that you are going to get it. Based on that, we are going to interpret it, whether it is a high positive, whether it is a high negative correlationship. So here, I just want to highlight here, the main objective of correlation test is to help us to understand the strength and direction of relationship between two quantitative variables. It is known as correlation test. Now somebody can ask me, so whether I have to use only two quantitative variables? At a time, you can also use good number of statistics, like more than two variables also you can use it. And you can also differentiate variables between one variable to another variable. For the sake of simplification, as many of you are at the beginning stage, at least more than 40-50% of you are beginning stage, in order to conduct the basic correlation test, we require two quantitative variables that must be either interval or ratio data. Okay. Now looking at the example, as I mentioned that there can be a positive correlation, there can be a negative correlation, there can be no relationship. This is called direction. Whereas when it comes to the strength of the relationship, based on the figure, based on the final result that you are going to get it, we are going to have understanding about whether it is a negative relation, negative positive or high positive. So this is the main objective of conducting correlation test. Now, when it comes to conducting correlation test, we have certain assumptions, we have certain requirements, one has to fulfill it. These are the basic assumptions. There are a few more assumptions like homoscedasticity test. I'll be talking about later on if some of you are interested. Otherwise, we have linear relationship, means there should be a linear relationship between x-axis and y-axis. Means we have two variables. linear, it must be positive or negative. There should be linear relationship between both the variables. It must be positive or negative relationship between the two variables that you are selecting it. Independence of observation, from the day one we are talking about it. Normality test, again from the beginning we are talking about it. What is normality distribution of the data? Whereas when it comes to correlation test, we are going to have two quantitative variables. So one has to check normality test, not only one variable. We have to check the normality test for both the variables, as both related to quantitative variables. One has to check normality test for both the variables here. Absence of outliers. As you're going to check it normality test, we're also going to check it out whether there is are there any outliers, if they are a high level or low level. So we are going to check it with the help of the box plot. What is outlier, how one can remove the outliers, how one can get rid of the outliers. Linear relationship means there must be positive relationship or negative relationship. There should be linear relationship. If one variable increases, either one variable must be increasing or decreasing. So one can able to see linearity, linear relation between two variables. Now, I request all of you, please check your Google Drive. As I mentioned from the day one, I have already updated your Google Drive. In that particular Google Drive, there is a name of the file is day 4. Please download the particular file. I believe that you must have already downloaded it. It's not something new we are doing today. I believe all of you are ready with your sample data set. The name of the file is day 4. Name of the file is day 4. I'm sharing my screen. Just a minute. Please open JAMOVI first. Please open the JAMOVI first. I hope all of you are working along with me. Yes, no? Okay, thank you. Thank you so much. This is the 4th day. I'm sure all of you knows how to open the file, how to import the file, how to export the files, right? Now just look at this particular file. Try to understand the data that we have with us. Try to understand the data that we have with us. We have income, we have consumption, knowledge, calcium intake, ICT, gender. Income, consumption, knowledge, calcium intake, ICT skills, gender. Now just come to the hypothesis. We have number of variables. With reference to the correlation test, we have income and consumption. We have a couple of variables, quantitative variables. Income is a quantitative variable. Consumption is a quantitative variable. Knowledge test score in quantitative. Calcium intake is quantitative. ICT skills is a low average height. Low average height means it basically is the ordinal data. Gender, we have male, female. Gender, we have male, female, we have it. Now, these are the two categorical data we have it. ICT skills, gender, we have categorical data. Remaining 4 variables are quantitative variables we have it. Now, when it comes to conducting the correlation test, we require 2 quantitative variables. Here, as a part of the correlation test, my null hypothesis is that there is no significant relationship between income and consumption. I'm saying that there is no relationship between income and consumption. Means if somebody's income is increasing, whether annual income, if somebody annual income is increasing, your annual consumption also increasing or decreasing it. If income increases, consumption also increases. It is called positive correlationship. If income increase, consumption decrease, it is called negative correlationship. I'm just repeating again. As a part of my null hypothesis, I'm framing that there is no correlation between income and consumption of the employees or respondents of your study. My alternative hypothesis, there is a correlation between income and consumption of the respondents. Now, as a part of this particular hypothesis, null hypothesis and alternative hypothesis, I just want to test it. Income and consumption. Now, what are the data requirements? First of all, I should see whether there is a linear relationship between these two variables or not. Whether there is a linear relationship between these two variables or not. Now, in order to understand the linear relationship between two variables, one has to conduct a scatter plot. One has to conduct the scatter plot. Now, in order to conduct the scatter plot, go to Analyze, Exploration. There is an option called Scatter Plot. Go to Analyze. Next one, Exploration. In the part of Exploration, there is an option called Scatter Plot. Just click on the Scatter Plot. Now, here I'm taking two quantitative variables. One is income. Second one is consumption. One is income. Second one is consumption. Now, the moment I have selected both the variables, in the right side, that is the results window, you can able to see that income I have selected x-axis, consumption it is y-axis. Now, it's showing the data. It's showing the data from somewhere 30, 40 onwards to 250, 280 plus somewhere, right? Now it shows how income is, what is the cursor, what is this particular graph is all about it. Now, for the first time, I'm conducting this particular scatter plot. I'm not able to understand how to interpret this particular scatter plot, how to analyze it, right? Now, if you look at the left side, we have some options. Linear relationship. I have to see whether there is a linear relationship between these two variables or not. So there are certain options. I'm just keeping a diagonal line here so that I can able to understand whether there is a linear relationship between these two variables or not. This is the linear, means I can able to see that this is a diagonal line and the data is clustered surrounding this particular cluster, this particular diagonal line. Though there are a couple of outliers, there are certain data sets not in this particular line. They are far away from this particular line. However, most of the data is falling somewhere close to the diagonal line. That is linear relationship. It means there is a positive correlation. Let me put it another way. There is one more option, smooth. I want some curve just to understand. It's not making any difference. Smooth. Okay. Now, second way, another, I can say that it is a tip to understand how to read it, how to understand it. If you look at this x-axis, right side bottom, we don't have any kind of respondents. Right side bottom, we don't have any kind of respondents. Similarly, left side on the top, we don't have any kind of responses. Right side bottom, we don't have any responses. Left side top, we don't have any responses. It means the person who got, for example, the person who got around 100 rupees income, the consumption was also around his 100. The person who is getting 250 rupees, nobody is getting below 100 consumption. If you look at this particular cursor, here, those are getting 250 rupees. If you take it daily income, okay, if you take it daily income, the person who is getting 250 rupees, his consumption is not less than 150. 150 is here. Somewhere it is 130, not less than 135. Means income is increasing, consumption also increasing. Let me put it the other way. The person who is getting 100 rupees, there are people who are getting 100 to 150. Nobody is spending above 150 rupees. especially I'm talking about the people range, the income range between 100 to 150. If you look at this particular consumption rate here, nobody crossed this particular stage, especially the target 100 to 150 people. Those are getting 100 rupees to 150 rupees. Their consumption level is somewhere here only. It means if one variable increases, other variable also increasing. If one variable increases, other variable also increasing. So this is a simple understanding of the scatter plot. There can be positive relationship, there can be negative relationship. When you can say positive relationship, if one variable increases, the other variable also increases, that is called positive correlation. If one variable increases, other variable decreases, it is called negative correlation. Now, we are able to understand there is a linear relationship between income and consumption. Second part is normality distribution. One has to fulfill the assumption of normality test. So in order to conduct the normality test, go to analyze, exploration, descriptives, go to analyze, exploration, descriptives, select the variables that you want to test the normality. I want to test the normality for the income. I want to test the normality for the consumption. So I have selected both the variables. I have selected both the variables, income and consumption. Now I have choice whether I want to put it row wise or column wise. So you can take the call how you want to present it in as a part of your paper, as a part of your research. It won't make any difference here, frequencies here, but I can choose row wise or column wise here. Now here there are 60 respondents in this particular data. There are total 60 respondents, and I don't see any data in missing values. It means all the respondents answered with reference to the question like income and consumption. So we don't have any kind of missing values. Now coming to the income level, there are 60 people. On average, that is mean value 164 rupees income per day. There are 60 people. On average, they are getting 174. There are also people, those are getting around 260, 250, even 270 also. But average means, on average, people are getting 174. Whereas when it comes to consumption level, their consumption level is 121. Mean value is 121. Okay. So this is a basic understanding of descriptive statistics. Basic understanding of the descriptive statistics. You can also see that minimum income is 80. There are people, minimum income is 80 and maximum income is 260 rupees. Similarly, consumption level, we have minimum consumption. Though the person is getting 80 rupees for a day, there are people who are spending 55 rupees. There are people who are maximum level, they are spending 191. Though they are getting around 260 rupees per day, but they are spending up to 191 means they are saving at least 71 rupees they are saving. I can say that 70 or 69 rupees they are saving on average. Not all, majority of the people. Now coming to the statistics point of view. Coming to the statistics, you can choose certain variables. I don't want to see missing values because there are no missings. So I can unselect it. I don't want to talk about median level here. I can unselect it. I don't want to talk about standard deviation. I can select it. Now coming to the normality test, we have Sperry-Wilkie test. As you can see that the moment I have selected, it is presenting the data. Sperry-Wilkie test, that is income we have 0.003. It means it is less than 0.05. It is less than 0.05. Whereas when it comes to the consumption, it is 0.19. It means it is greater than 0.05. It means if you look at the data, income data is not normally distributed. Income level data is not normally distributed. Whereas when it comes to the consumption, data is distributed normally. If you want to write the paper by using this particular data, you cannot conduct Pearson correlation test. As a part of the session, we are going to use this particular data. But if you want to write the paper by using this particular data like income and consumption, and you cannot conduct parametric statistical test. I just brought this particular data to show you that one can also conduct non-parametric test with the help of the same data set. Now, as one of the variable is not following the normality distribution, generally we cannot conduct it. Means we cannot conduct Pearson correlation. We also have some alternative tests. I'll talk about it. Now, I also wanted to see certain plots. Like I want to see histogram. Instead of talking data, I want to see income with the help of the histogram. Now you can see here, it shows that it is 0.003. It means data is not distributed normally here. It is not bell-shaped curve. Let's take for example, let me put it density. No, it is not coming bell-shaped, right? That's why we have got this particular problem. There is no normality distribution of the data. Whereas look at the consumption, you can able to get this shape. It's not exactly bell-shaped, but one can able to see that there is a normal distribution of the data. We got the bell shape of the curve, right? Now further, I want to understand, are there any outliers? Because one of our assumptions is that there should not be any outliers. So we have box plot, as we already discussed in yesterday's session. What is box plot is all about it. It shows the box plot of the income as well as box plot of the consumption level. So this is a QQ plot. It shows the data of how data is presented, graphical manner. This is for the income. This is for the consumption. So we are taking two important insights from this particular exercise. One is we are able to understand that there are total 60 respondents. When you look at average mean score, they are getting an average 174 rupees per day. When it comes to consumption, on average, they are consuming 121 rupees they are spending on it. Okay. And when it comes to the data, one of the variable is not having normality distribution of the data. Okay. Second one, with the help of the histogram, we are able to understand the same. Whatever the data is presented, same thing was reflected in the plot wise as well. Especially with the help of the plot, one can able to understand it. Now, we are able to fulfill linearity relationship. We are able to fulfill consumption normality, not income normality, but still we are going ahead with conducting the test. Okay. Now, how to conduct the correlation test? How to conduct the correlation test? Go to analyze. There is an option called regression test. As you can see under the analyze option, there is a regression. We have regression family. And within the regression, we have first one is correlation matrix. Go to analyze, select the regression test. The moment you click on the regression, you'll be able to see first option is correlation matrix. Select it. Now, please look at the data processing window. There is a middle window, correlation matrix. Now, in order to conduct the correlation test, we need two variables, two quantitative variables. One is income, we have selected. Similarly, we also selected consumption. So we have income is one variable, consumption is one variable. Instead of looking at the results right now, we need to understand what kind of test that we are conducting it. We all know that we are conducting correlation test. But at the beginning of the session, I also mentioned that we have different correlation tests. Right now, we are conducting Pearson correlation because we have two quantitative variables. At the same time, assuming we have seen the data, one of the data is not normal distributed, but still we are going ahead conducting it. If your data is distributed normally for both the variables, then only one can able to conduct the Pearson correlation test. If your data is not normally distributed, we have to go with non-parametric test, that is Spearman correlation test. I'm just repeating again. If you are able to fulfill the assumptions of normality distribution, if you are able to fulfill the assumptions of linear relationship, if you are able to fulfill the assumptions of having two quantitative variables, one can go for Pearson correlation test, that is parametric correlation test. As a part of parametric, we have Pearson correlation test. If you're not able to fulfill assumptions, then we have to go for alternative test, Spearman correlation test. Now, first we'll see what is Pearson correlation. Then we'll talk about Spearman correlation. Okay. Now we have selected by default Pearson correlation. We have it, and we are reporting the significance. And I also wanted to flag significant correlations. Means I want to put some star mark, flag significant correlations. As you can see that there are 3 stars. I also wanted to see the total number, like we got 60. I also wanted to see the confidence interval. I don't also want to see the confidence interval, like lower level and upper level. As you can see here, one can able to see the confidence interval, lower level, upper level. We got the confidence interval. And I also wanted to present correlation matrix plot. It's not required unless until if you want to fill the pages. Okay. Now coming to the results part. If you look at the p-value, our p-value is less than 0.05. Our p-value is less than 0.05. It means there is a significant relationship between income and consumption. There is a significant relationship between income and consumption. Now I understood there is a significant relationship. And with the help of a linearity relationship, we also understand there is a positive correlationship. But what is the strength of the relationship? I'm repeating again. One is looking at the p-value. There is a significant correlation between income and consumption of your respondents. With the help of linear relationship, with the help of the scatter plot, we understood that there is a positive correlation between income and consumption. Now, the correlation test helping us to understand not only whether there is a positive relationship or negative relationship, it is also helping us to understand what is the strength of the relationship. What is the strength of the relationship? Now, if you look at the strength of the relationship, it is a 0.95. It is a 0.95. It means, just look at the value. People will join late and will ask how to analyze the data, how to interpret the data. Every step, I'm explaining here how to interpret the data as well. Now, looking at our test result, we got the values 0.95. It is a plus. Now, how we are going to analyze it? How we are going to interpret the data? It is a very high positive correlation between income and consumption. This test results indicates that there is a very high positive correlation between income and consumption of your respondents. There is a high positive correlation between income and consumption of the respondents. 1 minute. There is. Okay. So this is all about how one can conduct the Pearson correlation. I hope things are clear. Let me go with the next test. Before going to the next test, I'll give the overview of this test is all about it. The main objective of conducting correlation test is to understand the relationship between 2 quantitative variables. And secondly, one has to fulfill the assumptions of your test. If you're able to fulfill the assumptions of the test, one can go for Pearson correlation. If you're not able to fulfill the assumptions of the correlation test, one can go for non-parametric test. That is, I'm explaining the concept. I'm not sharing any PPT here right now. Okay. So here, one has to take the call based on the assumption that you have fulfilled it. If you're able to fulfill the assumptions, you'll go for Pearson correlation. If you're not able to fulfill the assumptions, you'll go for Spearman correlation test. Analysis, interpretation will be the same. Only difference is that when it comes to non-parametric statistical test, you don't need to look at any assumptions. You don't need to see any assumptions, whether have you filled a normality distribution or not, whether have you filled are there any outliers or not. And similarly, if there is any categorical data, at that time also one can able to use Spearman correlation test. Okay. Now I'm sharing the simple linear regression. There is a next test. We are going to conduct it. Simple linear regression. Before talking about simple linear regression, let me give you the difference between what is correlation, what is simple linear regression test. As a part of correlation test, we are able to tell whether there is a relationship between two quantitative variables or not. But when it comes to the regression test, we are not only telling there is a relationship between two quantitative variables or not, we are also able to tell there is a cause and effect relationship. There is a cause and effect relationship. Let's take, for example, as I can see here, a couple of examples. The sales manager would like to assess if sales force training results in reduction in losses. Sales manager would like to assess if sales force training results in reduction in losses. For example, as a one of your organization, as a sales manager, you are looking at the performance of your employees, how they are doing, how they are performing in terms of sales, how they are convincing the people those are coming to your organization, to your shop. Right now, you decide that you have to conduct the training program. You are spending lakhs of rupees, thousands of rupees for training program, and you're expecting that the training is going to have some kind of impact on your employees' performance in terms of turnover, in terms of increasing the sales, in terms of interacting with your clients, in terms of receiving your clients. Okay, so there are a number of ways one can able to see that, one can able to assess the impact of it. Now here, training is the independent variable. I'm conducting training for my employees. I'm looking at it just because I have spent around 5 days. I asked my employees to go for this particular training program, whether it is having any kind of impact on reducing the losses, or I can say that whether it's having any kind of impact on increasing the sales, whether it's having any kind of impact on increasing profits or turnover, or I can also see whether how my employees are performing it, performance level. So it depends on the context wise. You are able to see what is cause and effect relationship between two quantitative variables here. It can be quantitative variables. There are so many tests we have it. Multiple linear regression, logistic regression test, okay, binomial logical regression test, hierarchical regression test. So there are big family as a part of regression test as well. As a part of this particular workshop, I'm going to talk about simple linear regression. It means whenever you have one independent variable, one dependent variable, you are going to conduct simple linear regression test. Till now, I was not talking about independent dependent variable because we're not seeing cause and effect relationship. Whereas when it comes to the regression test, I'm talking about independent variable, dependent variable. If I'm talking about one independent, one dependent, that is called simple linear regression. But in case, if I'm talking about one dependent, more than one independent variable, that is called multiple linear regression test. So the main objective of regression test is that one can able to understand cause and effect relationship between two quantitative variables. Just like previous correlation test, these are the few basic assumptions. We also have one more correlation assumption like homoscedasticity. I'll talk about what is homoscedasticity with the help of the data that we carry right now. So just like previous, we have same kind of assumptions. We have it as a part of the correlation test. Now, please look at your data set. Please open your data. For the sake of my students, maybe I can say that for the sake of other people, let me give one more example with reference to the hypothesis. There is no significant relationship between the amount of initial funding and the revenue growth of a startup. There is no significant relationship between the amount of initial funding, means initial funding. For example, we have students at GNLU. We have some startups. We are giving 2.5 lakhs as a seed grant. Now, I also wanted to see how much an average students are spending at the initial stage. The amount of money at the initial stage they're spending it, and how much impact is having on revenue growth. The people, those are having access to fund, seed grant, and whether it is having any kind of impact on their growth as a startup. So these are the two quantitative variables I have. One is the amount of initial fund, and second variable is revenue, the amount of revenue they're able to generate it. Let me give one more example. There is no significant linear relationship between gestation period and the birth weight of the baby. Now, gestation period, I'm sure all of you knows about it. What is gestation in terms of the number of weeks, number of days, number of months. Basically, talk about 38 weeks to 40 weeks as a gestation stage, delivery process, right? Similarly, we also have birth weight of the baby. The pregnant woman, the mother, who are able to complete 38 weeks of gestation, what kind of labor process they have undergone? Is it cesarean? Is it normal delivery? That is one context. That is one objective can I see. But in this particular object, in this particular hypothesis, I'm looking at it. The people, those who completed 32 weeks or 38 weeks or 36 weeks, baby weight in terms of pounds, in terms of weight, I'm looking at in terms of kilograms. So I'm seeing the two quantitative variables. One is gestation period and birth of the weight, birth weight of the baby. If gestation stage increases, like a number of weeks of the gestation increases, whether birth of baby weight is increasing or decreasing it. So I can able to see the cause and effect relationship between two quantitative variables here. Same data set. We are going to work on the same data set. Now, coming to the one more example here as a part of the data set. If you look at the data set, that is the day 4 data that we already opened. Let me share my screen. I hope my screen is visible. I hope my screen is visible. Knowledge and calcium intake. Knowledge test score and calcium intake. Knowledge test score and calcium intake. Now, here I have two quantitative variables. One is knowledge test score. Second one is calcium intake. Now, the people, those who attended, imagine that I'm just conducting a workshop. The main objective of this particular workshop is to increase awareness about diet. Increase awareness about diet. Diet in the sense, what kind of quality of food they have to take it, or what kind of fruits, what kind of intake, what kind of food varieties they have to take it. And if you're taking particular product, if you're taking particular food, how much of calcium you're going to get it in terms of milligrams. For example, after completion of the workshop, I'm conducting a test for 50 marks. The person who got 42 marks, like for example, as you can see here, the person who got 42 marks out of 50, what is her calcium intake? I have conducted the workshop that is on diet. After completion of the workshop, maybe after 2 months or after 1 month, I collected data from my participants, those who attended this particular workshop. I just want to know what is the impact of this particular workshop and how much score they got it and what is the calcium intake per day. So these are my objectives. Here. So as I'm conducting test for the 50 marks, there are people who got 10 marks, there are people who got 42 marks, there are people who got 38 marks. Similarly, I can also see that calcium intake, the people who got 10 marks, their calcium intake is 450 milligrams per day. The person who got 42 marks, calcium intake is 1050 milligrams per day. Now I can go manually, but if I'm collecting data from 1000 people, 100 people, 200 people, I can't do it manually, right? So with the help of this particular software, I just want to know whether knowledge is independent variable, how much extent it is influencing the calcium intake. How much extent it is influencing the calcium intake means I'm trying to see cause and effect relationship between two quantitative variables here. Let's take, for example, you can also imagine gestation and birth weight of the baby. Gestation and birth weight of the baby. Now, in order to conduct the regression test, one has to fulfill the same assumptions that you have done as a part of correlation test. So first we'll go and test whether do we have normality test or not. So in order to understand the normality test, I request all the participants, you no need to respond to the questions. The people, those are not attending, if those are not looking at the email IDs, they'll ask me these kind of questions, please. Okay. So in order to understand the normality test, go to analyze, exploration, go to analyze, exploration, descriptives. Here we are going to conduct normality test. Here we are conducting normality test for the two variables. One is knowledge, second one is calcium. One is knowledge, second one is calcium. So I have taken two variables. We have 60 respondents. If you look at the mean score, let me put it in row wise. Now there are 60 people and we have conducted test for 50 marks. And on average, there are people who got knowledge. Mean score is 28. Means overall 68, there are people, mean is 28. Whereas when it comes to calcium intake, on average, 60 people are taking 764. I'm talking about mean score. Okay. Whereas when it comes to the marks, minimum score is 10, maximum score is 48. Minimum calcium intake is 450. Maximum calcium intake is 1085. 1085. Now, after understanding the basic descriptives, just come to the normality test. Sperrio-Wilkie test. Look at the results here. Knowledge test score, it is greater than 0.05. We got the result 0.06. It means it is greater than 0.05. It means our data is distributed normally. I'm repeating again. As a part of the normality test, our test result p-value shows that it is greater than 0.05. It means knowledge test score data is normally distributed. Similarly, when it comes to the calcium intake, it is 0.048. It means it is close to 0.05. So we can consider that there is a normal distribution of the data. It is close to 0.05. One can able to take it. One can also go ahead with conducting regression tests. There won't be any much problem here. Okay. So we are able to understand that our data is distributed normally. Further, if you also wanted to see plots, you can see that not exactly bell shape, but you can able to see that some kind of curve. One can able to see that. Let me put it density. It shows the how data is distributed. We can able to see the bell shape curve. Box plot help us to understand are there any outliers. It shows there are no outliers. QQ plot, this is a graph. It shows how data is presented. There are a couple of deviants. So we are able to confirm with our data is distributed normally. Second one, we have to conduct whether there is a linear relationship between these two variables or not. In order to understand whether there is a linear relationship or not, one has to take the help of scatter plot. In order to conduct the scatter plot, go to analyze, exploration. There is option called scatter plot. Now here, it is asking x-axis, y-axis. Now, which is independent variable? Dependent variable, knowledge and calcium intake. We have two variables. One is knowledge, second one is calcium intake. Which one is the independent variable? Knowledge is independent variable. Thank you. Okay, calcium intake is dependent variable. So knowledge, we are going to keep it as a part of x-axis. Calcium intake, 1 minute. Knowledge is part of x-axis. Calcium intake is y-axis. Okay. Now, look at the scatter plot here. How data is distributed. Now, it is not very clear to me. I'm not able to understand how to read it. So I can take the help of linear plot. Now, as you can see, there is a diagonal line. It shows if one variable increases, other variable decreases. There are also a couple of data. Like for example, the person who got 20 marks in terms of knowledge test score, he or she also having calcium intake roughly around 1100 plus, okay, 1050 plus somewhere close. But except one or two, maximum you can able to see if, for example, 10 to 50. We are conducting knowledge test score for 50 marks, 10 to 50. If you look at it here, if knowledge test score increases, calcium intake increases. Let me put it smooth curve. It shows how data is presented here. Now, right side bottom, we don't have any data. Let's say, for example, the person who got 40 marks, he or she is getting around 70, 700 or 680 marks, 680 calcium intake. There are a couple of people, but on average, it shows that if one variable increases, other variable also increasing. It means if knowledge test score increasing, calcium intake also increasing here. Let's take, for example, can you see anyone who is getting between 40 to 50? Is there anyone below 600 calcium intake? No. Nobody is taking below 400 milligrams per day, especially the people those are having score of 35 to 50. Almost everybody is getting above 700, and especially the people those are between 40 to 50, they are taking on average minimum 900, 850 plus, right? As you can see here, it must be 45 or 43. Calcium intake is above 1000. Similarly, you can also see that the person who is getting, who got 10 marks, the person who got 10 marks, what about their calcium intake? Only except this candidate, the person is having around test score around 22. And here she is taking around calcium intake above 1000, around 1050. And it's very clear that if one variable increases, other variable also increasing it. So there is a linear relationship between knowledge test score and calcium intake. Now, so we are able to understand two assumptions, normality test as well as linear relationship. Now, please go to analyze. We are going to conduct a regression test. Please go to analyze, regression test. There is a third option, linear regression. In order to conduct the regression test, go to analyze, select the linear regression, Now we got the data processing window. Here we are going to select the variables. Our dependent variable is calcium intake. And independent variable is knowledge test score. Now, I have selected both the quantitative variables. Don't look at the results right now. Come to the assumptions. We already conducted all the assumptions like normality test, QQ plot, everything. Select residual plots. If you want to do it most simple manner, you also don't need to do that. You don't need to talk about as a part of your interpretation of the results also. But just I want you to explain it. You can select the residual plots. Coming to the model fit. Come to the model fit. Select F test. By default, R is already selected. R square is already selected. In case, if you are conducting multiple linear regression, you can also select adjust R square. Right now, as a part of simple linear regression, we need to select R. R square is already deselected by default. We only have to select F test, that is ANOVA test. F means ANOVA test. Next, come to the model coefficient. We are selecting standardized estimates. I'm repeating again. After selecting the variables, dependent variable, independent variable, we are coming to the assumptions. As a part of the assumptions, if you select residuals, well and good. Otherwise, you can simply leave it also. But I just want to explain that. So I have selected residuals. Next one, please come to the model fit. As a part of simple linear regression, we need R square, R, and F test. R square, R is nothing but correlation test. I'll talk about it with the help of the test results. Select R, R square, F test. Come to the model coefficient. Select standardized estimates. Select confidence interval. It's not required right now. Now come to the results. Please come to the results. We'll go one by one. We already covered descriptive statistics, like there are 60 people, on average, how much intake they have it, what is the test score they have it, everything we have discussed as a part of descriptive statistics. Now, coming to the regression test results. Model fit measurement. There is option called R is there, R square is there. R is nothing but correlation test. Means you are seeing the relationship between knowledge test score and calcium intake. If you are conducting regression test, it means first thing you are going to do it correlation test. Without understanding the correlation, we cannot go for regression test because we are seeing the relationship, linear relationship, right? Now, R value is 0.81. R square value is 0.66. It is a correlation test score, R square value. Now, how to interpret the findings? How one can report as a part of your research paper, as a part of your research findings? Now, I can able to see that there is a correlation between knowledge test score and calcium intake. If you look at the R value wise, it must be high positive correlation test. R value. There is a high positive correlation between knowledge test score and calcium intake. You are going to write one line. Second point here, very important point as a part of the correlation test. As a researcher, I'm able to say that knowledge test score is influencing the calcium intake. 66%, whatever the changes happening in calcium intake, 66% knowledge test score is influencing the change in calcium intake. I'm repeating again. For example, I can see that there's a student named Summer. I don't know whether he's here. He must be there. I'm just asking, he got around 40 marks out of 50. This is a candidate, name is Summer. He got knowledge test score 40 out of 50. Now his calcium intake must be somewhere 1000 or 1050. Now as a researcher, I'm predicting. The main objective of conducting regression test is you are able to predict based on your test score. I'm predicting that 66% of the change is happening in calcium intake due to change in knowledge test score. For example, he got 40 and after 1 week again I am conducting score, he is getting around 41. Means there is a 1 unit of change is increased. Whatever change is taking place is mainly due to calcium intake. It means out of 100%, 66% whatever change you are seeing in calcium intake that due to change in knowledge test score. It means remaining 34% you are not able to explain. There are so many other factors also influencing it. Maybe media, maybe he or she might be watching TV, maybe he or she might be having family members who belongs to doctor family or healthy family. Maybe their parents might be telling time to time what is quality food, what kind of food they have to take it. Maybe you can also see their socio-economic background also. There are so many factors influences. If somebody is having good quality of life, it means they must be having higher standard of living. They must be having good economic conditions. They must be belong to good income family. So there are so many factors also here, right? But in this particular case, as a researcher, I'm saying that whatever change I'm seeing in calcium intake, whether it is increasing or decreasing, 66% knowledge test score is influencing it. I hope is it clear to all. Remaining 34%, there are other factors which cannot be explained. Maybe you can take other factors also. Like if you're having data about family income, if you're having data about their annual income or whatever, you can able to take it out. Okay. So this is one of the important insight as a part of the regression test. One thing is correlation test, that is R value. Second is R square value. It's talking about how much your independent variable is having influence on the dependent variable. There is cause and effect relationship. You are able to talk about it. Second one, coming to the ANOVA test. Where is F test here? ANOVA. Yeah, sorry. As you can see the left side here, please look at the left side. Please look at the left side under model coefficient. Under model coefficient, please select ANOVA test. Please select ANOVA test here. Now you can see the result here. There is ANOVA test. Now, the ANOVA test, the test tells us there is a significant relationship between knowledge test score and calcium intake. Our p-value is less than 0.05. It indicates that there is a significant relationship between knowledge test score and calcium intake. That is the main objective of conducting ANOVA test here. Coming to the model coefficient, very important point. The main objective for conducting regression test is to know this particular point. Now, in this particular point, I mentioned that what are the change I'm seeing in my participants, in my respondents. 66%, I'm confident that just because there is change, knowledge test score is influencing the calcium intake. Now, this particular model coefficient, I'm taking this particular model, I'm going to generalize it. Let's take, for example, when I'm seeing knowledge test score, 40, and as I mentioned, Mr. Summer, he got 40, and after 1 week, knowledge test score is increased 40 to 41. It means 1 unit of change, 1 unit of knowledge test score is increased. It leads to 13.5 milligrams intake is going to increase. I'll repeat again here. With the model fit, I'm saying that 60% of the change in calcium intake is due to change in knowledge test score. But here I'm saying that 1 unit of knowledge test score, as Summer is getting from 40 to 41, means earlier he got 40 marks, now he is getting 51 marks. As a result of change 1 unit, as a result of increasing 1 mark from 40 to 41, it is going to increase 13.5 milligrams intake. This is all nothing but prediction. You are going to predict. For example, as a part of human resource management, we have a lot of data. We used to deal with a lot of data, right? Like employee turnover, employee performance, employee, are they going to leave your job? One can also predict it. We have a lot of predictive. One has to predict it. What is going to happen to your organization? How you are going to retain your employees for a longer period of time? What is the employee satisfaction point of view? Now, with the help of the data set, we are able to predict it. If 1 unit of change in knowledge test score leads to 13.5 milligrams intake, it is going to increase. 13.5 milligrams calcium intake is going to increase. Okay. So this is all about regression test. I don't think this is the most simplest way I will be able to explain it. Now coming to the residuals. Now, coming to the residuals point, there is a concept called homoscedasticity. I don't want to explain it because many of you are very new to the concept. If you don't know this concept also, one can be able to go ahead with that. But let me, if those who want to take it, they can take it. Homoscedasticity means you are seeing the change. You are seeing the change here, right? You are assuming that the change is going to be the same. There is going to be homogeneity in terms of the change. There is going to be the homogeneity in terms of the change. Now, residuals, knowledge test score, calcium intake. Just like linear regression. Now, it is a homogeneity. If somebody want to say that heterogeneity means your data will be here also. But data is not there. Data is there like this. There are 1 or 2, but one can be able to see that data is scattered. Data is clustered around this particular line like this. If you put line here, one can be able to see that it isn't going in a particular line, just like a linear relationship wise. Similarly, here also you can be able to see here, right? So in case data is not here like this, that is called heterogeneity, but this is called homogeneity, means the data is like this. If you put the curve, one can be able to see data is clustered in the similar line, scattered in the similar line. You can also forget about it. You can take the model fit value. You can take the ANOVA. That is nothing but ANOVA result. the value is less than 0.05, it means there is a significant relationship between knowledge test score and calcium intake. Let me summarize it briefly. For the scholars, for the PhD scholars and the students, those who want to write a report, we need to take three or four important values. First one is relationship, that is correlation test value. Correlation test value, it indicates that there is a high positive correlation between knowledge test score and calcium intake. R square indicates that as a researcher, you are able to predict 66% whatever the change that you're seeing in calcium intake is due to knowledge test score. And similarly, you're also going to conclude that there are 34% of change, whatever change that you're seeing in calcium intake, due to other factors, which researcher cannot be explained with the help of the variables that you have selected it. Okay. Second one, with the help of the ANOVA test, we can able to see that as the p-value is less than 0.05, we are able to say that there is a significant relationship between knowledge test score and calcium intake. And third and last important point, for every 1 unit of change in knowledge test score leads to 13.5 milligrams intake. 13.5 milligrams intake is going to change the calcium intake. So this is all about simple linear regression. Let me go to the next part. Chi-square test. Chi-square test. As you can see, the chi-square test, there are two types of chi-square test. We conduct chi-square test whenever we have categorical data. Whenever we have categorical data means whenever we have nominal data, ordinal data, one can go for chi-square test. Within chi-square test, we have two types of tests. As a part of this particular workshop, I'm going to talk about chi-square test of independence. Chi-square test of independence. In order to conduct the chi-square test of independence, we need two categorical variables. It can be nominal data, it can be ordinal data, or it can be one nominal, one ordinal. So choice is there. Basically, there must be qualitative data, nominal and ordinal data. Second one, independence of observation. As we are discussing from the day one, independence of observation is one. Expected frequency assumptions. Expected frequency assumption means we are going to look at the difference between expected frequencies and observed frequencies. We are going to see the difference between expected frequency and observed frequency. Expected frequency means you are expecting something is going to happen. This much is going to be there. And observed means you are going to test it and you are going to see the results. Based on that, you are going to see the difference between expected and observed differences. Contingency table. Before conducting the correlation chi-square test, one has to prepare the cross tabulation. You can call it as a contingency table. You can call it as a cross tabulation. One of the important point, as many of you might be knowing it, when it comes to the preparing cross tabulations or when it comes to preparing chi-square test, if your sample size is less, and you can see that there will be rows and columns, right? If you are preparing cross tabulation, one can able to see rows and columns. The expected frequency count should not be less than 5. I'll talk about it with the help of the data. I will explain this particular part with the help of the data. Right now, please go to the same data set. Same data set. Okay. Look at here, we have ICT skills, gender. Now ICT skills, we have three types of answers. Low ICT skills, average IT skills, and high ICT skills. Means you have collected data, you have collected quantitative data, and you have converted that quantitative data into ordinal data. That is easy to convert it. Now we have ordinal data, low, average, height. Low, average, height, we have orders. This is called ordinal data. Second variable, we have nominal data, that is gender. We have two types of categories, male category, female category. So in order to conduct the y-square test of independence, we need two categorical variable. In this particular case, we have ICT skills is one variable and gender is another variable. Now there is a possibility that 2 into 2 table, 2 into 3 table, it means gender, we have two categories, male and female. And I can also take low and high. That is called 2 into 2 table. I think we'll talk about at the time of results. Now, in order to conduct the chi-square test, my null hypothesis is that there is no association between gender and ICT competencies. There is no difference. There is no association between gender and ICT competencies. Means I'm saying that whether it belongs to male category or whether it belongs to female category is not having any association with having ICT competencies, that is information and communication technology skills. Now, in order to conduct the chi-square test, go to frequencies. In order to conduct the chi-square test, that is test of independence, go to frequencies. Select independent sample. Select independent sample, that is nothing but chi-square test of association or chi-square test of independence. Go to analyze, frequencies, independent samples. Independent samples. You can make adjustments your screen as per your requirement. Now I need two variables. One is gender. Second one is ICT competencies. I need two variables. One is gender. Second one is ICT competencies. Now, as you can see here, data is already presented. Right now, don't go to this particular part. Come to the statistics. By default, chi-square test is already selected. So you don't need to select it again. By default, chi-square test is already selected. Now coming to the right side part. Already it was selected confidence interval, 95% confidence interval. Coming to the nominal, this part, pi and Karmar's value. Please select it. Please select the pi and Karmar value. I'll explain it, what it is. Come to the cells. I'm repeating again. After selecting the variable that you want to test it, we need two categorical variable. One is gender we have selected. Second one we have selected ICT competencies. Then test of independence, that is chi-square test we have selected. Confidence interval we have selected. Then pi and Karmar value, I'll explain it what it is. Next, please come to the cells. Now select expected counts and observed counts. Select observed counts already selected by default. One also has to select expected counts, row percentages, column percentages. One can select it. Row percentages, column percentages, you can select it. Come to the plots. As it is a categorical data, we have only one option, bar chart. If you don't like this particular chart, you can change it. Like for example, right now, rows, now it's showing male, female here, now column wise. So as per your requirement, you can keep changing it. Now come to the data set right now. We have prepared contingency table. Total number of respondents, we have 60. Now we are going to interpret this particular findings. We are going to analyze this particular findings. Like for example, out of 60 respondents, 52% of the respondents belongs to male category. 52% of the people belongs to, the 52 people belongs to male category. 8 people belongs to female category. Means, okay, I hope you're able to understand it. Similarly, one can also see out of 52 people, male, how many people having high ICT competencies, how many people are having average ICT competencies, how many people are having average ICT. So one can able to analyze it by going through this particular table. Now that anybody can do it whenever you get the time. Now the point that I want to highlight, I want you to remember is that this is called expected frequencies. This is called expected frequencies. This is called expected frequency here. Now here we have row. This is called cell. This is called cell. This is called cell, right? These are all called cells. Now it is expected that your expected cell count should be minimum 5. Expected cell count should be minimum 5. Now here this is 5 point. This is 1.47, 1.33. Minimum 80% of your expected cell count should be more than 5. Please note down if you want it. Minimum 80% or 75 to 85% of the expected cell count should be minimum 5. If it is crosses more than 80%, more than 30% of the cells have any kind of problem, it is going to have impact on your preparation of chi-square test. I'll repeat it again. You are seeing expected count, like for example, in this particular case, 33.80, 9.53, 8.67. Imagine that this particular count is less than 5. Like for example, in this particular case, it is 1.47. It means it is less than 5. 1.33, it is less than 5. If you take overall cells, if more than 25% of your 20% of your cells have expected count less than 5%, it is going to have impact on your generalizing your research findings. It is going to have impact on validity of your results. So people generally won't prefer to go for chi-square test. Okay. Now, coming to the p-value. Our p-value is greater than 0.05. It means there is no association between gender and ICT competencies. It means there is no difference whether he belongs to male category, whether he belongs to female category. Both the genders having equal amount of ICT competencies. There might be differences, but it is not having any significant. Means as a researcher, whether what are the difference that you're seeing, is it occurring by chance? Are there any significant associations? You might be seeing slight changes, but was it significant impact? Was it having any kind of significant association? No. There is no any significant association between gender and ICT competencies. Now, as our p-value is greater than 0.05, we don't need to talk about pi value, Karmer value. But just in order to understand it, imagine that our p-value is less than 0.05. Imagine that our p-value was less than 0.05, and we are going to conclude that there is a significant association between gender and ICT competencies. Now, there are two values we have. One is pi value, second one is Karmer value. Right now, JAMOVI is still updating. Still, they need to update what is pi value, what is Karmer value, we got it. What is pi Karmer means? Let's take for example. If I'm having 2 into 2 table, I'll take the values of pi value. I'll tell you what is 2 into 2. In case if I'm having 2 into 3, I'll take the Karmer value. Now, right now, if you look at our data set, this is called 2 into 3, means male, female, 2, 3. 1, low is 1, average is 2, high is 3, means the number of categories that we have it. 2 into 3, this is called, so we are going to take the values of Karmer's value. Karmer's value, this is basically talking about effect size. Effect size. I'll talk about it, what is effect size. I'll repeating again. If we have 2 into 2, like male and female, low and height. Low and height. It is called 2 into 2 table. Whereas when it comes to 2 into 3 or 3 into 2, it can be reverse way also, like 3 into 2 also. It can be 3 into 2 also, 2 into 3 also. In that case, if it is 2 into 2, you are going to use pi value. Right now, JAMOVI is still they're updating on it. Right now, they don't have any values. And when it comes to the 2 into 3 tables, just like this, 2 into 3 tables, we are going to take the values of 0.192. But what is 0.192? As a part of effect size. As a part of effect size. If the value is less than 0.3, it means low effect. Low effect. For example, we are saying that what significant association. If the value is less than 0.05, we are saying that there is a significant association. But how much effect is having? Low effect, medium effect, high effect. If it is less than 0.3, low effect. If it is less than 0.5, medium effect. It is above 0.5, it is called high effect. This is all about chi-square test of independence.